Need a few more examples of rational expressions?
As you wish.
Taking a look at the first example here, what do we need to do? Well, we got to take a look and see if I have anything in common that I can take out of each term in the numerator. So looking at this, I got 4x plus 24. Well, common factor, I can get rid of a 4. So we divide everything by 4. I'm going to get x plus 6. Now I got to take a look at the denominator. Is there anything here I can take out? No. I don't have anything in common among the x squared, the 8x, and the 12. So then we're going to go through and try to factor this quadratic. First terms in each going to be an x. This sign tells me that the signs are the same. This one's going to tell me they're both positive. So I put x plus, x plus. Now I need factors of 12 that will add up to give me 8. So I go through all the different options, 2 and 6. So now I got to go through and simplify. Well, is there anything that both numerator and denominator have as a factor I can get rid of? The answer, of course, is yes. I can get rid of the x plus 6 here and get rid of this x plus 6. Numerator then, I'm going to have a 4. My denominator is going to be an x plus 2. But, of course, can't be as simple as just going through and doing that. We've got to figure out what values of x will not be allowed. In other words, what values are not going to be allowed for x because of the fact it will give me a 0 in the denominator. So as I look here, I got to go with both of them. X plus 2. If I have a negative 2, then this part's going to be 0. That's not allowed. So then x is not allowed to be negative 2. It's also not allowed to be negative 6. Alright, so let's go to the next example. This one looks a little different, but it's still not that bad. I'm going to take a look at the numerator. I only have one term, so there's nothing to worry about. My denominator, though, I do have some stuff I need to get rid of. 9n squared minus 9n. I have a 9n in common. So then I divide each term by 9n. I'm going to get n minus 1. Let's see, the numerator and denominator now. I've got this n that I can get rid of. 6 and 9 have a common factor of 3, so when I divide 6 by 3, I get 2. Divide this 9 by 3, I get 3. Now I'm just looking to see what's left. I've got a 2 in the numerator. In my denominator, I still have that 3, and I still have the n minus 1. So in this case then, n, and it doesn't really matter what my variable is, it's all going to be the same when I go through and try to work on this. So n cannot be 1, because if I substitute a 1 in there, I'm going to end up with a 0. Then I also have to look at this n here. So not only is it not allowed to be 1, but it's also not allowed to be 0. Those are the two values of n that cannot happen. So let's take a look at this example down here. Anything in common among 6x and 24? Yep. So I'm going to cross this out. I'm going to factor out the common factor of 6. And then I get x minus 4. Looking at the denominator, I can factor that. First terms in each are x. This tells me the signs are the same, both negative. Now I need factors of 12 that will add and give me 7. So what multiplies to give me 12, but when added will give me 7? So that's 3 and 4. So that's now factored. Now I got to go through and get rid of whatever I have in common. So in this first part, the numerator, x minus 4. In my denominator, I also have an x minus 4. I'm left with just 6 in the numerator, x minus 3 in the denominator, and x is not allowed to be, same thing we've been doing for a while here, it's not allowed to be a 3, and it's not allowed to be 4. Because if I put the 3 in, I get a 0. If I put the 4 in, another 0. Alright, so last example, for this particular section at least. Taking a look at this example, if you notice, it's not quite in the same order that we're used to, so let's try to fix that. I'm liking having m squared first. Not so much right here. So if I notice, the sign's just wrong. It's the wrong one. So I'm going to factor out a negative 1. By factoring out a negative 1, what that will do is that will change every single sign here. So now I'm going to have m squared minus 8m minus 9 That's more in the order that we like to see. And then if I look down here, wait a minute, I still have m squared minus 8m minus 9. So what ends up happening here is that both of these things are gone. But I still got to go through and factor this. Why do I need to factor this? Because I got to figure out what values of, in this case, m, are not going to be allowed. So I have an m here in the first term. I have an m here in the second, not term, factor rather. So I'm looking for factors of 9 that differ by 8. This tells me the signs are going to be different of one another, so I'm going to have a plus here, we'll say, and a minus here. Factors of 9 that differ by 8. It's going to be 9 and 1. This tells me that the larger one is going to be negative. So I have a negative 9 here, and I have a 1 here. Alright, so looking back at these examples that we have here, notice how both of these are going to be gone because they're exactly the same. So when I factor this, I'm actually left with just negative 1. However, I still have to talk about what the variable cannot equal. M is not allowed to equal negative 1. It's also not allowed to be 9. Alright, so that's simplifying rational expressions. Hopefully we're good to go.